Okay, so we're given this formula here, and in part A it says the initial velocity of an object is 4 meters per second. So you can relate that to the letter U, yeah, because this is U is the object's initial velocity. So initial velocity is 4 would mean U is equal to 4. So maybe we'll write that there so it's clear for us. After travelling a distance of 64 meters, well, if we look here, it says S is the distance travelled. So we can say S is 64. Its velocity is 20 meters per second. So V then is the object's velocity after it has travelled a distance of, in this case, 64 meters. So the V will be 20 then. Okay, so find the acceleration of the object. So all we need to do then is just substitute in values into this formula. Okay, so we know V to be 20. So we're going to square it, of course, because it's V squared, equals then to U squared. So we know U is 4, so it'll be 4 squared, plus then 2AS. Now, that, of course, means you multiply it. 2 by A, which A, of course, is what we want to find out. It says acceleration, yeah, which is the letter A, times then S, which we know is 64. So we can work this out here. That's going to be 400. 4 squared is going to be 16. And of course, when you're multiplying these here, you can multiply the numbers, put the letter at the end, so it doesn't matter about the order, put the 64 in front. So you get then 2 times 64, which is 128 times A. So just a bit of algebra here now. What I would do here, this 16 is sort of on its own, so take that over. So of course, when you take it over, it's a positive 16, so when you take it over, it becomes a negative 16. 128 times A, well, maybe we'll just write that as 128A, just to sort of see the algebra there, how simple it can be. Take that away, so we get 384 is equal to 128A. And finally then, to get my A, of course, because I'm timesing these, I need to take the 128 over and divide to get my A. So A works out then to be 3, okay? And the units of acceleration, not that they ask for it, are meters per second squared, okay? So in part B, it says assuming the acceleration remains the same, so in other words, A is going to be 3, show whether or not the object has reached a velocity of 25 meters per second when it is at a distance of 100 meters from the start. So we're given A to be 3, okay, same acceleration. The distance is 100 meters. And we want to show that the velocity is actually reached 25 meters per second. So we want to show that V is this. We also, of course, know that the initial velocity was 4, velocity at the start. So what I need to do now is just substitute these values into the equation here to work out what V is. See if it has reached 25 meters per second. So U is 4, so 4 squared. A is 3. And S is 100. So we can work all that out in one go on our calculator. And we get 616. Of course, to get V then we need to square root, don't we? Because we've got V squared here, so take the square over. Opposite of squaring is square rooting. And I get V to be 24.8. Okay, so the units of velocity meters per second, not that we need to write it, but you can clearly see it hasn't quite reached it yet. So the answer there can give us the statement there, not yet. Okay, so not yet, as V is less than 25.